everyone. Today we are starting chapter 5, which is going to focus on this thing called rectangular approximation methods. Basically, what it is a way to figure out the area underneath a curve by approximating the area by using rectangles. So we're going to see actually first an example of reason why we do this, and then we're going to actually switch then to functions that we would do this for as well. Okay, so here's our kind of contrived example of somebody trying to figure out how far they drove to work. Okay, so if you were a mathematician or someone who just likes to play with numbers, you would maybe calculate or look at your odometer basically and see, oh, every 2 seconds, I'm going to calculate my speed. I'm going to see what the speed is. And this is in notice feet per second here. So we're noticing that this person over 10 seconds, their speed went up, but it didn't go up consistently. So it went up for 6, then 4, then 8, then 6, then 6 again. So the speed is not consistent, which means we would need a process to figure out the total distance traveled. Let me remind you that distance is rate times time. So a lot of times if you know your average rate, like 40 miles per hour, and you traveled for 1 hour, then you would say you went 40 miles, right? But this isn't consistent here, so we're trying to figure out an exact distance we went. So here's how this is going to work. Excuse me. So we're going to start by making it very simple and looking at our first two rectangles. So first two intervals, first interval from 0 to 2. So again, we're going to remember distance equals rate times time. So the time here, this time interval is 2. And one way we could look at it is to say, oh, well, at time equals 0, I've measured the speed to be 30. So my rate would have been 30 and my time would have been 2. And that means I would have traveled 60 feet. Okay, but that's using this lower value, the smaller value for the rate. What if instead I look at the same time interval of 2, so here's the 2, but instead of using the 30 at the initial starting time, we use the 36, that was the second measurement. So now our rate is 36 and our time is 2, which means that with that estimate, you went 72 feet. So this creates two different types of estimates. It creates a lower estimate and an upper estimate. And we know we created the lower one by using the lower value, and we created the upper estimate by using the larger value. In this case, it happens to be on the left side, and in this case, the value happens to be on the right side. So we're going to use this idea to do this problem twice. First, we're going to create a lower estimate, and we're going to create, notice 1, 2, 3, 4, 5 rectangles. Then we're going to do the upper estimate with 5 rectangles, but using the larger values. And then we'll make it a little more exact from there. Okay, so all of these have equal time intervals of 2. So they're all going to be multiplied by 2. So this one is 30 times 2, 36 times 2, 40 times 2, 48 times 2, and 54 times 2. And notice that we're not using the 60 because that value is an upper value, so we're not using that. So you're going to multiply all these by 2, or you could add all of the numbers, the 30, 36, 40, 48, and 54 together, and then multiply the whole thing by 2. But either way, what you get when you add it all up is 416 feet. Okay, so now we're going to do the same thing, but create rectangles starting on the other side of the picture. So we're going to, again, ignore this 0, 30 and instead create rectangles using the height on the right-hand side. So now my height of this right rectangle is 60, and then my next rectangle going to the left will be 54, 48, 40, and 36. So we used this side for each of the rectangles. So now it's 36 times 2, 40 times 2, 48 times 2, 54 times 2, and then 60 times 2. Add these all up, and the distance that was traveled was 476 feet. Okay, so then this question says if you chose the lower estimate, which is 416 feet, for your approximation, what is the maximum amount your approximation can differ from the exact amount? So remember, this is the lower, and I hope you recognized that the upper was 476. Both of these are approximations and they're both wrong. This one is too small and this one's too big. So what that means is if you subtract the two, you will get the maximum difference between your estimate and the actual distance. And this is a total of 60 feet. So at most, your estimate is off by 60 feet. That would be if you chose the lower and the upper was actually the correct estimate, which granted, we don't know exactly because we don't know what's happening at the times in the middle, but neither one of these are probably correct. Okay, here's number 2 for us now. So we're going to fill in some additional values into this table here. So instead of just giving times of 0, 2, 4, and 6, now we're going to fill in some times in the middle, but you're going to make up the times. So you're going to put your own values, or I'm going to do it my way, and then you can choose to do it your own way separately if you'd like. The main thing that we're going to make sure that we do is we keep the graph to be non-decreasing. We don't let the values go down in the middle, and don't select the average. So I'll show you what I did here. So in the original problem, you went from 0 to 2 and then 2 to 4. So now we're going to say, hey, we came up with some additional speeds at times 1, 3, 5, 7, and 9. And these are the speeds that we got. They are increasing in value, but not the averages, at least not all of them are the averages. So now we would want to find what the new best upper and the new best lower estimates would be. So here are what I get for both of these. So you can see that my lower estimate is when I take and I add everything from 30 to 57 together. And notice now that the heights between each of them are a 1. Makes it a little easier to calculate. And the same thing over here, this height is a 1. So assuming that, this is approximately close, you can see that we're getting better best upper and best lower estimates. Now the difference between these two is only 30 compared to what we had before, which is significantly better. All right, moving on. Okay, so we're going to use this idea with a graph. So I'm starting off with a basic function so that you can start to understand it. So we're going to start off with x squared, and we're going to do what's called this rectangular approximation method. And again, these are sometimes called, I think I spelled that wrong. Pretty sure I spelled that wrong. These are called Riemann sums. So sometimes the R in this formula sometimes stands for the word Riemann, but usually we think of it as rectangular. So this is the left, sometimes called left-hand rectangular approximation method, meaning start on the left side and don't use the height on the right side. You can create as many rectangles as you want, but I hope it makes sense that the more rectangles you have, the better your estimate. Okay, so if we're going to create 2 rectangles, I looked at this, let's have this go from 0 to 4, since that's what's showing up on my graph here. So I'm going to create 2 rectangles out of 0 to 4. The widths are going to be 2 each. Okay, so now I need to figure out the heights. And for the left, my height should start at the left value. So we should start at 0 for my height. And then my second one, the height will be at 2. The 2 is a little bit easier to see, and I hope I can draw this well with this pen. Okay, so here's my rectangle starting at 2 is the height. On the left side, there actually is no rectangle because the height is 0. So what you're doing is saying, okay, the width is 2. The height's going to come when I substitute 0 into my function, and my function is x squared. My width is 2 for the second rectangle, and my height comes from when I substitute 2 into my function. So this whole thing just becomes 8. Notice how much area is left over. This is clearly not a good approximation. All right, I'm going to erase this, and we are going to then do with 4 rectangles so you can see how this works. So 4 rectangles, I'll do in red, means that I'm going to break it into 1, 2, 3, 4 rectangles. So my first height will be at 0. So again, no rectangle here. But now my next height will start at 1. So it goes like that. Then at 2, only over to 3. And then at 3, over, to 4. Not doing a good job drawing. All right, here we go. So my widths are all 1. And again, you could factor that out front. Height is happening when you substitute 0 in. Width, 1. Height is happening when I substitute 1 in. Then 2 in. Then 3 in. You should only have, remember, 4 rectangles. So I have 0 plus 1 plus 4 plus 9, which is 14, is the area, the approximate area under this curve. Again, a lot of empty space that hasn't been filled in, but it's a little bit better than the previous one. And if I did more rectangles, I would get closer, and more rectangles, and I would get closer. Okay, so now we're going to do what's called RRAM. So RRAM is when we start on the right side. So that means my rectangles are going to start with the larger, or the right-hand side. So again, if my domain is from 0 to 4, my rectangle will have, I'll have a rectangle at 4, which means I'm kind of going backwards when I create them. Okay, so let's go ahead and create it backwards. And then as you move forward and understanding it, you don't have to go backwards. So 2 rectangles, my rectangle I'm creating at 4 has to go all the way over to 2. Really bad rectangles. Oh my gosh, that's really bad. Okay, so my first rectangle, notice how far off it is there by a lot. All right, that's better. And then my second rectangle will have, the height will actually be at 2, so it'll be going over this way. So when I go to do my calculations, again, my width is 2, and my rectangle that I'm creating is starting at a height, or over at 2 to get the height. So 2 squared here, and then a width of 2, and my next height's coming from 4. 4 times 2 is 8. 16 times 2 is 32. This one gives me an estimate of 40. That's way over now as opposed to way under. So then let's create 4 rectangles and see what it looks like. Okay, a better eraser here. Okay, so if I want to create 4 rectangles, again, that means each width of the rectangle is going to be 1. And let's work at it from the left side, but still using the right rectangle so you can see how this works. So the height of my first rectangle would be at x equals 1. And my second rectangle's height would be at x equals 2. And my third rectangle is at x equals 3. And the fourth rectangle is at x equals 4. Okay, so same process. My widths are all 1. Let me actually factor that out anyway, so we're not looking at it. And I'm doing 1 squared plus 2 squared plus 3 squared plus 4 squared. So this comes to 1 plus 4 plus 9 plus 16. This is 25, and 5, this is 30. Significantly smaller than the only 2 rectangles. All right, we're now going to do the midpoint approximation method, which can be kind of tricky because you have to sometimes use fractions when we're doing this. Not for the 2 rectangles at least, but we will have to use fractions for the 4 rectangles. Okay, so 2 rectangles means their width is going to be 2 this way to get 2 out of this, and the height is going to occur at the midpoint between these 2 x values. So the height is going to occur at 1 for this first rectangle, and then the height will occur at 3 for the second rectangle. So the nice thing about this is you can see that there's some over here and some under. Some over, but then some under. So it shouldn't be horrible. So I'm going to factor out the width of 2. Then it's going to be 1 squared plus 3 squared, which is 9 plus 1 is 10 times 2 is 20. So this area is now 20. So here's where it gets a little tricky when we want to use 4 rectangles, at least for this one, is because we're going to have to use fractions. So my widths are 1 again, so that is nice. And then for each of these, the heights are going to occur in the midpoint between 0 and 1, 1 and 2. So I'm going to write them over here. So my first height is going to occur at a half squared. My second height is going to occur at 3/2. So 3/2 squared. My third height is going to occur at 5/2. So 5/2 squared. And my last height is going to occur at 7/2 squared. Okay, so I've got 1/4 plus 9/4 plus 25/4 plus 49/4. So when I add all that up, I end up with 84/4, which is 21. That's kind of interesting to me because 4 rectangles gave me an answer that's almost the same as 2 rectangles. And both of these are a better estimate, I think, than the original, well, the left and the right that we did, because those had so much either over or under, where this is a little bit of both. All right, I hope that made some sense, but we will go over this tomorrow at the beginning of class again. Please make sure that you are writing down any questions you might have as you went along. Go back and watch the video if you need to. See you tomorrow.